Hi. Last lecture we have discussed K-maps, right? 2 variable K-map, 3 variable K-map. What are the rules of K-map we have seen. Now let us see the next part, 4 variable and 5 variable K-maps. Okay, right. Keep the heading 4 variable K-map. See, we have 4 variables A, B, C, D. As we discussed in the last lecture, here we take the possibilities of 0, 0, 0, 1, 1, 1, 1, 0, gray code. Here also 0, 0, 0, 1, 1, 1, 1, 0. Here you can understand 0, 0 meaning is A bar, B bar. Here A bar, B. Here A, B. Here A, B bar. Like that. So this one represents min term 0. 0, 0, 0, 0. A, B, C, D is the format we need to read. This one represents 1. 0, 0, 0, 1. This one represents 0, 0, 1, 1 means this box represents min term 3, 2. Like this 4, 5, 7, 6. Here 1, 0, 0 represents 8, 9, 10, 11, 12, 13, 14, 15. This is the pattern. Okay, each box represents one min term. Now let us take one example. Minimize the function f of a, b, c, d equal to sum of the minterms 0, 1, 2, 5, 7, 8, 10, 13, 15. Let us do this question. Okay, first listen. We need to minimize the function f of a, b, c, d equal to sum of the minterms 0, 1, 2, 5, 7, 8, 10, 13, 15. Let us use a 4 variable K-map and let us do the minimization. So sum of the minterms 0, 1, 2, 5, 7, 8, 1, 0, 1, 0 is 10, 13, 15. These are the minterms we have in the K-map. Let us do the minimization. We can form quad. Is there any possibility of octet? No, octet is not possible. Is there any other quad possible? Yes. All the 4 corners can form one quad. These 2 and these 2, these 2 and these 2, because of the adjacency property between this cell and this cell, this cell and this cell, pairing or grouping is possible between the adjacent all the 4 corner cells as a quad. Is it clear? Here they are adjacent only because of cyclic adjacency property. This cell and this cell is having adjacency property, and same this and this is having adjacency property. So we can make a quad with all the 4 cells. What about this one? You can take a pair like this, anyone is okay. As I told earlier also, K-map will always give minimized answer but need not be unique. You can take anything, both are valid answers. So let me take this. Then what is my function f? For this quad, you tell me, for this quad, this is B, here this is 1, okay, here it is B. What about this? Here this is 1, means D. Is it clear? In this quad, In this column, 1 is common, that is B. In this row, 1 is common, that is D. So B into D plus all the 4 corners. In the first and last, what is the same? 0 is same. So B bar. In the first and last, what is same? This 0 is same. So it is D bar. Lastly, this pair A0, B0. And what is common in these 2 rows, 2 elements in these 2? What is common? First 0 is common, that is C bar. So what is the expression? A bar, B bar, C bar. So this is my function f. Okay, copy it. That is about your 4 variable K-map example. Please copy this. Okay, right. Let us take one more example. Right. So similarly, directly K-map is given. Okay, say for example, write the minimized expression of the following K-map is asked. Okay, here one way is they may give expression. They can ask the to draw the K-map and minimize it. Or sometimes they can give the minimized directly K-map. They can ask. They can give. They can ask what is the expression, minimized expression. Let us see that. Here, let us check whether is there any octet possible. No. Quad S. This is also one quad. This is also one quad. What about this one? It should be covered like this. You may have the doubt, sir, is there any other quads are possible? Yes, there is one quad possible. We don't take that. I will tell you the reason also. This quad we are not taking because this here is redundant. Why it is redundant, I will explain. See here. if you observe here, you may have the doubt, sir, we have taken this, why don't we take the quad which is highest compared to pair? Why you have taken pair? For example, you take this quad, okay, after taking the quad also, you see this one is left over, that one should be covered by this pair only. Once you have covered this one by this pair, you observe in this quad, this one is already covered by this pair, this one is already covered by some other quad, okay, this one also covered by some other quad, this one also covered by some other quad. So all the ones are already covered by some other quads, okay. You may have the main doubt you will be having is, what about this, sir, this one is covered by pair, you are giving preference to pair compared to quad, why? Please observe here the difference. Even you take the quad, because of covering this one, we should compulsory take this pair. Yes or no? We should compulsory take this pair. So definitely, whether you take the quad or not, you are already taking this pair. Once you have taken the pair, all the ones of this quad are already covered. So it will become redundant. Okay. Now let us write the expression. What is your F? For all the four corners quad, what is this? B bar. What is common in the first and last? 0 means D bar. For this quad, what is common first and last? 0. First and second, what is common? 0. B bar, C bar. Plus, for this quad, 0 0 means C bar, D bar. 3 quads are finished. Okay, all the four corners, this one and this one. Lastly, this pair. For this pair, 1 1 means AB. What is common here and here? C. That is because 1. So A, B, C. This is the minimized expression. Okay, copy it. Right. Next. Please take the question, write down the question. Minimize the function. Minimize the function. Minimize the function f of ABCD. I'll write also, please write. Minimize the function f of ABCD equal to sum of the minterms, that is sigma m of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, up to 0 to up to 15. Okay. What will be the answer you will be saying? What is the answer? You may say immediately, sir, it is sum of all minterms, your answer is 1. Wrong. Please observe very carefully. You have 1 to 15, but 0 is not present. So it is not sum of all minterms. It is missing one minterm. What is that minterm? 0. See here. Sum of all minterms except 0. So here, can I form any octet? Yes, octets are possible here. So this is one octet. Any other octet is possible? Yes. This is an octet. Is there any other octet possible? Yes. Lastly, this one is left over. You have different choice. You may take the one singly, pair, quad or octet. Always go for highest possibility. Because if you take a single one, why should we go, sir? You understand. Take a single one. What is the expression? A bar, B bar, C bar, D. 4 terms, 4 literals. Okay, literal count is 4. If you take a pair like this, A bar, B bar, what is here? D. Literal count 3. If you take a quad, it is C bar D. Literal count is 2. If you take octet, here nothing is common. Here what is common? Just D. We should write it as D, which is 1 literal count. That's why we should go for always maximum combination of maximum possible adjacent cells. Okay. So let us write the expression for this f equal to, what is f? Starting from the bottom bottom octet. What about this octet? In this octet, here first and next, in these two, what is common? 1 is common. 1 means here A. Okay. In this row, nothing is common. You observe. You add all this, it will get 1. That is C bar D bar plus C bar D plus CD plus CD bar. Okay. Similarly, next, in this row, what is common here? B plus in this column. Okay, this column and this column. It is one octet, right? In this octet, in the vertically nothing is common. Horizontally, what is common? First 1 is common. That 1 is called C plus. For this, vertically nothing is common. Horizontally, what is common? 1 is common. That we call it as D. So what is F? A plus, B plus, C plus D. Okay. So this is the minimized expression. But you may, I will suggest you one thing. Instead of doing this much, here in this particular case, what is the easiest way to do it is, it is sum of 15 minterms. Then if you, it is SOP. If you write POS, only 1. What is that? You have 0 only here. 0 means in the POS, what is the expression? No, 0 means no bar. So A plus, B plus, C plus D. Is it clear? What I am saying is, these are all minterms. What is the max term? You have only 0 is the max term. You can write the expression with the help of minterms or max terms. Here, since it is only one max term is present, to directly write the expression with max term, it is always easy for us in this particular case. Okay, because only one max term, no need of minimization, directly write the expression, you get the same. Okay, so this is how to make the answer in this case. So it is not sum of all minterms. In this case, what is that? 1 is not your answer. Please copy it. After copying the solution, please copy the next figure. What is the answer you say in this question? What will be the answer you are expecting here? Is there any octet possible here? No. Quad? Yes. So you may say the answer will be, this is one quad, this is one quad, and this is the pair. Wrong answer. You observe very carefully here. 0, 0, 0, 1, 1, 1, 1, 0. Okay. What about this? 0, 0, 0, 1, 1, 0, 1, 1. So it is not given properly. First we should exchange these two columns. Then only we should minimize the K-map. Yes or no? So see here. So here, please exchange these two and redraw the K-map. What is the solution we'll get? Observe. Here first 1, 1 comes, next 1, 0 comes. So this column should be shifted here. Now see here. Octet and pair. Right. Now what is the expression? Ref is equal to, for this octet, nothing is common here. What is common here in both? D plus, this is D, plus in this pair. For this pair you observe 0, 0 means A bar, B bar. In this 2, what is common here? First 1 is common here. 1 means C. Copy it. So be careful. Sometimes to confuse you, they will give 1, 0, 1, 1 format also. You should exchange first, then you should minimize. Right. That is about the expression. What is that? D plus A bar, B bar, C. Next question. Write down. Minimize the function f of abc equal to, minimize the function f of abc equal to, you can see here, sum of the minterms 1, 2, 4, 7. Sum of the minterms 1, 2, 4, 7. Minimize the function f of abc equal to sum of the minterms 1, 2, 4, 7. Okay. Right. Let us try to minimize this. A, B, C. Sum of the minterms 1, 2, 4, 7. Yes or no? 1 means 0, 0, 1. 0, 1, 0. 1, 0, 0 is minterm 4. 1, 1, 1 is minterm 7. Now you observe. Is there any possibility of minimization like a quad or a pair or octet, anything here? Nothing is possible here because there is no adjacent cells. This is a very special case. You observe the K-map is containing all the elements diagonal only. This is the special case we call diagonal adjacency. What is this? This is called as diagonal adjacency. What is this diagonal adjacency, sir? See here. Whenever the K-map contains only diagonal elements, there is no groupings of pairs, squads, anything, only diagonal elements, then it is called as diagonal adjacency. Whenever diagonal adjacency occurs, you cannot minimize the K-map further. Whenever diagonal adjacency occurs, you cannot minimize the K-map further. And your answer, the expression will be either XOR or XNOR or a combination of XOR and XNOR. Okay, I am repeating. Whenever the K-map contains only diagonal elements, then it is called diagonal adjacency. We cannot minimize the K-map further in that case. Your answer will be either XOR or XNOR or a combination of both. If each minterm contains odd number of ones, as you know earlier, XOR. Even number of zeros, XNOR. If both of these conditions are not possible, you can check the answer will be possibly either XOR, XNOR combination. We can see that. Okay. First, copy this. I'll give that statements. Copy it. Right. Please write down the point. Keep the side heading diagonal adjacency. Keep the heading diagonal adjacency. Diagonal adjacency. Write down. Whenever the K-map contains only diagonal elements, then it is called diagonal adjacency. Diagonal adjacency. Next line. Whenever diagonal adjacency occurs, we cannot minimize the K-map further. Whenever diagonal adjacency occurs, we cannot minimize the K-map
further, the output expression is either XOR or XNOR or a combination of both. Either XOR or XNOR or a combination of both. Next line. If each minterm contains odd number of ones, then XOR. If each minterm contains odd number of ones, then XOR, comma. If each minterm contains even number of zeros, then XNOR, comma. Otherwise it is combination of both XOR and XNOR. Okay, let us see the solution for this. Here, let me check whether we cannot minimize this further. Just for writing purpose, you can write as a XOR or XNOR. That's all. Okay. Each minterm contains odd number of ones or not. Let me check. 0, 0, 1. How many ones? Only one. Odd or even? Odd. 0, 1, 0. How many ones? Only one in the minterm. That is odd. 1, 0, 0. Only one. Only one means odd. 1, 1, 1 means triple 1. In this minterm, how many ones are there? 3 ones are there. But 3 means what? Odd. So all the minterms contains odd number of ones. So answer is XOR. Let me check for XNOR also. 0, 0, 1. How many zeros are there? 2 zeros are there. Even. 0, 1, 0. How many zeros are there? 2 zeros. Even. 1, 0, 0. 2 zeros. Even. 1, 1, 1. No zeros. Even. So whenever you have even number of zeros, your answer is also equal to A XNOR B XNOR C. So your answer is either XOR, A XOR B XOR C or A XNOR B XNOR C. Sir, how both? I already told, whenever you have input contains odd number of variables, A, B, C, 3 variable condition, XOR and XNOR both are same. That's why your answer is both XOR and XNOR. So since both are same, because A XOR B XOR C is the same as A XNOR B XNOR C for the 3 input case. Whenever your number of input is odd, both are same. Okay, copy it. Now, let us see the next question. What is this? Sum of the minterms 0, 3, 5, 6. 0, 3, 5, 6. Right. Is there any quads and pairs? Nothing is possible. Here also it is a kind of diagonal adjacency. There is no meaning for this dots. Just for understanding purpose I am making this. Okay. It is not a pairing. Just to show you, it is a diagonally adjacent cells. So here also diagonal adjacency condition is satisfied. So whenever diagonal adjacency is satisfied, you can understand here answer must be XOR, XNOR or combination of both. Let me check. 0, 0, 0. How many ones? No ones. 0, 1, 1. How many ones? 2 ones. 1, 0, 1. How many ones? 2 ones. 1, 1, 0. How many ones? 2 ones. It is not satisfying odd number of ones. It is having all even number of ones. Let me check. 0, 0, 0. 3 zeros means odd. 0, 1, 1. 1 0 means odd. 1, 0, 1. 1 0 odd. 1, 1, 0 means only 1 0 is present odd. So it is not satisfying even number of zeros or odd number of, it is not satisfying even number of zeros or odd number of ones. So it is neither XOR nor XNOR. So your answer will be
A XOR B XOR C complement, or you can also say complement. You can check the expression, it will satisfy, it will be equal to A XOR B XOR C. You can write this expression and check the convert into canonical form and check whether it will be giving this one or not. Your answer will satisfy both of them. Both are valid answers. Okay. So it is complement of XOR or XNOR. Okay. This function is, that is either this or this is the answer. Both of them are right answers. Okay. So if it is satisfying odd number of ones or even number of zeros, XOR XNOR. Otherwise, it is a combination of XOR and XNOR. Okay. Copy it. Okay. Next. Let us take one more example. Represent, take this, f of a, b, c, d equal to a XOR b XOR c XOR d. Represent f of a, b, c, d equal to a XOR b XOR c XOR d in K-map. In K-map. In K-map. In K-map, represent f of a, b, c, d equal to a XOR b XOR c XOR d in K-map. Let us represent this function in the K-map and check. Okay. What is the condition we discussed earlier? Whenever your input contains odd number of ones, then XOR output is equal to 1. So 0, 0, 0, 0, even number of no ones. 0, 0, 0, 1, only 1, 1, odd. 0, 0, 1, 1, 2 ones, even. 0, 0, 1, 0, odd. 0, 1, double 0, odd. 0, 1, 0, 1. It is not odd number, even number. Please understand. Number of ones in the representation. Say 0, 1, 0, 1 contains how many ones? 2 ones, even. 0, 1, double 1. How many ones? 3 ones, odd. 1, 1, double 0, even. 1, 1, 0, 1. How many ones? 3, odd. 1, 1, 1, 1, 4. 1, 1, 1, 0, odd. Like that we feel it is the condition. Now you can observe, is it diagonal adjacency or not? Every time it will satisfy. You can take all the 4 also. There is no meaning of this bubbling. So this is
Definitely a diagonal adjacency condition. So whenever your answer is a XOR case or XNOR case, always it will satisfy diagonal adjacency condition. Okay. If it is XNOR, in this case you will get the reverse part, because 4 variable condition XOR and XNOR are complementary to each other. We know that condition already. Okay. If it is odd number of inputs, XOR, XNOR, same, even, they are always complementary. Now please listen here. One important condition. Suppose, forget about XOR and XNOR. If you write the output expression for this K-map, how you write? There is no possibility of making any pair or quad. Yes or no? There is no possibility of making any pair or quad or octet. So we should write individual terms only. Forget if it is not XOR, XNOR representation. Normally A bar, B bar, C bar, D plus A bar, B bar, C, D bar. Like that you write all. Lastly A, B bar, C, D. How many terms are present in the output expression? 1, 2, 3, 4, 5, 6, 7, 8. You take any other function, you cannot get more than 8 terms in the output expression of a 4 variable K-map. I'll show you. Please understand. Say, let me take the same function. Right, this is my function. If you take this function, okay, you take any other function, you keep one anywhere in this figure, you keep one, it will form pairings immediately. So my output expression may contain same number of terms or less than that, but not more than that. You take one here, immediately it will form pairings. You take one here, it will form a pairings. Okay, like this. So in this function, okay, in this function you take any other condition, you take anywhere one, okay, then your output expression will be more than or equal to this number of terms in the output expression, I am saying, okay, but not greater than this. So you can see in any 4 variable K-map, you take any function, you take any 4 variable K-map, output expression contains maximum how many? 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can also generalize, because for XOR gate, output expression contains how many number of terms? I have given the formula. In a n input XOR gate, your output expression contains 2 power n minus 1. You can check here, 4 variable na 2 power 4 is 2 power 4 minus 1. So 2 power 4 minus 1 is 3. 2 power 3 is how much? 8. So you can generalize this. In any n variable K-map, output expression contains maximum how many? 2 power n minus 1 number of terms in the output expression. You cannot have more than that, because if you have more than that, it is saying that you have missed something. Okay, you take any function, it maximum number of terms in the output expression is 2 power n minus 1. So if it is a 3 variable K-map, 2 power 3 minus 1, 4 terms you will get in the output expression of any 3 variable K-map. Okay, copy it.